Now, after being able to understand, after being able to explain elasticity and also the stiffness of a material, or that is the spring, which is the major apparatus we are using for this question, we are going to be looking at the Hooke's law and what is stated. Now, before I go into Hooke's law, I want you to take note of these purple color values. Purple color values. Now, look at that purple color value is called extension. That means additional length on the spring due to the force applied on the spring. That is due to the pulling of the spring. The additional length, the further length that the spring will grow when you pull it is called extension. And in this lesson, I am representing it with this purple color value, which can also be called displacement, but a traditional name or a conventional name for it is extension. Now, I want to increase my spring constant so that I can have um, a reasonable, okay. Now, okay, look at this part now. Let's start afresh. Let me go back to 0 point. Let me go to at least 500 Newton per meter. Then let me put um my my equilibrium position value. Let me also put my force. Okay, now at this point now you see nothing has happened to the spring. Therefore, the extension or the displacement is zero. You see? Now, let me tell you, when I apply the force to 100 Newton, what happened to the purple color value? It has given you 0.2, right? Good. If I increase it, okay, let me start by saying when it is at 25, you have 0.050 meter. When I increase it to 53, you have 0.106. And when I increase it to 100, you have 0.200 meter. Now you see what happens? The more the force is increasing, the more the extension is increasing. And that is how what Hooke's law stated. And for the sake of exam and questions, I want us to define or state Hooke's law. And Hooke's law states that provided the elastic limit of an elastic material is not exceeded, the extension E of the material or spring is directly proportional to the applied force. Now, like I was saying, the extension E will be increasing as the force is increasing, as we saw from the demonstration. And that is what Hooke's law stated. And we are going to back this up with a few calculations. Now, let us solve the first calculation from what Hooke's law stated. I'm going to be using the values on this screen, on this place to show you what I mean. Now, let's say if a spring of elastic constant is 500, I'm going to put it at 500. Now, good. No, let me put it at 500. Good. Now, it's stretched. Let me remove the force so that you will not know the value of the force. It's stretched by 0.192. So I'm going to be stretching it until I have 0.192. Okay. I'm stretching 898 is 200, no? 19, sorry. no, 19. Okay, let me go this way. 196, 194, 192. Now, God, the force is already recorded here, but no problem. We are going to solve the calculation to see if we will be able to get 96 Newton. And I'm going to show you in a live board. I'm going to do the calculation in a live board. Now look at it as I'm doing it. So from this question now, this is the force constant, which is given as K. And this is the extension. Remember, if you pull, it will go. If you pull, so the more the force, the more it increases in length. And that is what is called extension. Then I don't know the force because I say find the magnitude of the force applied. There is nothing special about the word magnitude. They just want you to find how big the force is. Now, according to Hooke's law, Hooke's law says that the force is directly proportional to the extension. That means the force, the extension, apply again, extend. So the more you are pulling, the more it's increasing. Now, this K is the constant of proportionality, which is given as the force constant. That is the force constant, and that is K. It was set as 500 Newton per meter. So, if I use this equation, then F is equal to K is 500 multiplied by 0.12. Then F is going to be 96 Newton. If you use, say this multiplied by this, you're going to have your answer. And that is the first question. We are going to do the second one. The second calculation says, in this second calculation now, I'm going to give us force. And I'm going to remove the displacement. Now let's assume that I put the force at 33 Newton. And then let me reduce my force constant to 350. That my force constant is 350. Now, what will be the extension? Now we are going to solve to see the extension. But before then, let me show you the answer. Let me put extension. Extension is 0.094. Okay, 0.094 as the extension. Now, I'm going to solve it in a live class for us to see if actually we will have 0.094. Okay, so in this one now, we have been given force to be 33 Newton. We are giving force to be 33 Newton. And we are given K to be 350 Newton per meter. Now, the question should be, it's a very wise question to ask. When do I know it is force? Whenever only N is written. If you see N, that N means Newton, and that Newton represents force. Just like dollar represents, just like this sign represents money for this country. A particular country has this symbol. Nigeria has this symbol for money. So whenever you see this symbol, you know it's Nigerian money. So whenever you see this N, you know it is force they are talking about. And whenever you see Newton per meter, you know we are talking about spring constant or force constant. And the two of them can only be related by this formula, Ke. And then the question says we should calculate the increment in the length of the spring. That means when the force was applied, by what length did it increase? That is what we mean by increment, and that simply means extension. So in this case, I'm going to say that extension is unknown, and that is what I'm here to find. So this is 3 under force, which is equal to K 350 times E. So E becomes 3 over 350, and E is measured in meter. So if you use your calculator to punch it, you're going to have 0.094 meters. This is the value of the extension which was recorded by the system. Thank you. Please, if there is anything you don't understand on the course of this lesson, please don't forget to comment, to ask me using the comment section. And remember, it is not good to watch this kind of video without subscribing. Please hit that subscription button and share the video, and also like. Thank you. Until I see you in the next class.